Hello everyone. So we are here to see a small demonstration of the architecture created by me, similar to Autosar. So in this, we have created three SWCs: Fault Manager, IO Handler, and UART Manager. Uh, these are generally created empty. I have written some code, which I will be back in a minute. So this has all been generated by our autocode generator written in Python. So it looks something like this. So for example, which we would be looking today is like fault manager, and for this I would like to keep a cyclicity of 1 millisecond. Click add. So it's been added. Then I will keep it as IO handler, keeping cyclicity as 3 milliseconds. Next would be okay, fault is done. So UART manager, cyclicity again 3 milliseconds. Then I click next. So this screen is mostly to tell the code generator that from which SWC what type of data would be generated. For example, for fault manager, we would be generating alerts for over voltage, keeping it as a uint8 add. So you see a variable has been added. So for IO handler, for now I would just keep it to ignition. Again, ignition status, maybe better word. Then for UART, I would like to keep this as a dummy variable. We'll click next. On this screen, we would like to understand what type of uh, data we would like to read in our SWC. For example, in fault manager, we would like to get the ignition status. So it would be like added here. In IO handler, maybe something like over voltage, and also in UART like to get both. So ignition and click generate. I won't be clicking generate for now because I have already written some code that would go away if I click generate. So I like to show you with this generated code. So let's see the demonstration. So on your screen, you might already see some board there. It's STM32F407 discovery board, which I would be using today. But this architecture is agnostic to it, but some with some configuration, obviously. Okay, so it's been compiled. Okay, debugger is getting connected. So as I don't have a USB to UART converter, we would be using SWV console here to see the prints coming up. So as soon as I press play, we'll see ignition is set to off on the screen, continuously printed by our our UART manager. It's reading the ignition variable sent by the IO handler. So it's been reading that. So this ignition is currently set to the blue user LED here. So as soon as I press this, you see on screen that ignition is set to on, leaving it set to off, on, off, on and off. Okay. And this just to for the demonstration purpose, we like to create a over voltage failure. For example, if one of the pin is short to 5 volts, we see two indications. One is fault to VBAT print on the screen, and also you can see a blue LED coming up on the board. So fault manager is detecting the uh, fault and sending it to UART handler to print, and also to the IO handler to switch on the LED. So for continuously, if it detects for 300 milliseconds, it's switched on. Even if, for example, if you see, if I press uh, the user LED, you see the ignition is on. So uh, both things are working simultaneously. Remove this, you see only ignition of print on the screen and also the LED is off. So if I press it again, VBAT fault again, and ignition to set it on. Okay, so we are back to zero. I will stop this. Okay, so each IO handler it is having its own static file which creates an abstraction with the lower level. So that's how it works. Okay, thank you for your attention. Have a great day ahead.